Hey guys, in this video we're going to look over CNCM Online Round 1 Problem 1, written by me, Eli Park. So let's read the problem first. Kukisuki has 8 hoodies, and he may wear any of them throughout a 7-day week. He changes his hoodie exactly 2 times during the week, and will only do so at one of the 6 midnights. Once he changes out of a hoodie, he never wears it for the rest of the week. The number of ways he can wear his hoodies throughout the week can be expressed as 8 factorial divided by 2 to the power of k. Find k. So, before we start, let's try to visualize here this problem a little bit. So each of these circles is kind of represent a day in a very rough manner. And we know that since he can only change in one of the 6 midnights, and they're represented by the bars dividing each day. So we can divide this into 2 parts, into basically almost solving 2 separate problems. The first is going to be on what nights is he going to change? The number of ways to change his hoodies, expressed in another way. And then once we know on what nights he's going to change his hoodies, we can then find the number of ways to choose hoodies given which nights he changes the hoodies. So if we multiply these 2 together, we're going to get our answer, and then we can extract our answer at the end. So let's first find a number of ways he can change his hoodies. Well, remember we have, going back to our very rough drawing, we know that there are 6 nights. And if we go back to the problem, we see that exactly 2 times during the week he changes. Which means that means all we need to do is select 2 of these 6 nights to change, right? And exactly 2. And we know that now we know that is exactly 6 choose 2, because we're picking 2 nights out of 6, which equals 6 times 5 times 4 times, that's just 6 times 5 divided by 2. Sorry, my bad. I was thinking about 6 choose 4 divided by 2 times 1. And we'll leave it like this for now, just so we don't have to compute as much later. So now let's find a number of ways to choose his hoodies given the nights he changes. So going back to our very rough diagram, we know for each of the given 6 choose 2 ways, we want to find a number of ways he can choose a hoodie. So let's pick 2 arbitrary nights that he changes his hoodie. So let's say he changes his hoodie on this night and on this night. So that means in these 2 days he wears 1 hoodie, and on these 2 days he wears 2 hoodies, and on these 3 days he wears 3 hoodies. And we can see that for each way of the 6 choose 2 ways that he changes his hoodies, we see that there are basically 3 segments of days where he wears distinct hoodies. And we know that this hoodie and this hoodie can't be the same, because in the problem it states that once he changes out of a hoodie, he never wears it for the rest of the week. So and we also know that he has 8 hoodies if we go back to the problem, which means that there's 8 ways to choose this hoodie, and then the first hoodie that he wears, and then the next one, since he's already worn one of them, when he changes he has 7 hoodies left to choose from, and then when he chooses again he has 6 hoodies to choose from. So that means that we have in this part 8 times 7 times 6. So now all we need to do is extract the answer. Well, going back, we earlier said that we just need to multiply this value to this value. So we can multiply that together. Oops. We'll multiply that together. Let me change to blue pen. Actually, I'll keep it in purple. Times 8 times 7 times 6. And this is going to be our answer. And just to make our computations a little easier, instead of having to multiply that all out, I made the answer so that you have to, so in the form, if you remember the form, it's 8 factorial over 2 to the k. So let's do some rearranging. So let me clear our board a little bit here. If we clear our board, then I'll just write on top of this. We know that this is equal to 8 times 7 times 6 times 6 times 5 over 2, which is the same. When 6 times 2, we know that, 6 is just the same thing as 3 times 2, right? So this is looking a lot like 8 factorial, and then we know that all we're missing, and we can just add a 1 at the end, we're just missing a 4 right here. So that means we can add in a little 4 right there, and we'll multiply a 4 down here. We'll multiply 4 down here. So this simplifies to 8 factorial divided by 8, which is equal to 8 factorial over 2 to the 3, which means that k is equal to 3, and that is our answer.